This video is about domain and range of our trig functions. So let's start with a little review. We have our ratio identities, that's sine over cosine is tangent and cosine over sine is cotangent. And our reciprocal, where 1 over sine is cosecant, 1 over cosine is secant. And then also 1 over tangent is cotangent. And we're going to be using these to figure out issues with our trig function. So if you remember with sine in a unit circle, sine is our y coordinate and cosine is our x. So if we were to flip these, cosecant would be 1 over y, and cosine is 1 over secant is 1 over x. Tangent we also know is y over x, and cotangent is x over y. So the issues we get are denominators. That's when we get our undefined. So if you remember 1 over 0, this is undefined. In fact, any number on top except for 0. It's undefined or undetermined. But no matter what, this is bad for our domains. So if you look at each of our fraction, you have cosecant theta. So for what angles is x equal to 0 from 0 to 2 pi? So x is equal to 0 at 90 degrees or pi over 2. And it's also equal to 0 at 3 pi over 2. So anything with a denominator of x has issues at these two numbers. If I were to plug pi over 2 into secant theta, this is going to come out undefined. And if I plug pi over 2 into y over x, this is going to come out undefined. Let's also look at the y. When is y equal to 0? Well, that's at 0 degrees, or 0 pi, or 2 pi. And then also at pi. So 0 pi and 2 pi are where we're going to get issues for anything with a y. So cosecant and cotangent have issues at 0 pi and 2 pi. So if we look at the calculator, you can see tangent of pi over 2 gave us an error. These are issues for tangent because it's a denominator of x. And x is equal to 0 at pi over 2 and 3 pi over 2. So tangent's going to have issues with that. And then cotangent is reciprocal. So again, that's now when the y is 0. So here at 0 and pi, and you can see 1 over tangent. So cotangent of 0 and cotangent of pi also give us errors. So our domain, sine and cosine, there are no denominators. So its domain would be from negative infinity to positive infinity. All real numbers can be plugged into it. Tangent and secant, now tangent and secant, you see, have a denominator of x. And so when is x equal to 0? At pi over 2 and 3 pi over 2. So we know that x cannot equal pi over 2, and x cannot equal 3 pi over 2. Okay? Now, we have issues here constantly. So you have to add to it 2 pi k, and add to it 2 pi k. Now, if you think about putting this together, you have pi over 2, and the next point is 3 pi over 2, and then pi over 2. They're actually occurring every pi over 2, every pi. So you can instead say x cannot equal pi over 2 plus pi k, where k is an integer. So it can be any number other than pi over 2 or 3 pi over 2 or a repetition of that. And then cotangent and cosecant, well, cotangent and cosecant, that's when the y is equal to 0, so it's these. So at 0, pi, 2 pi. So again, you would say when x is equal to 0 plus 2 pi k, it can't work. And when x is equal to pi plus 2 pi k, it can't work. So putting that together, you would get x is equal to 0 plus pi k, so it's really just pi k, where k is an integer. So if I were to plug in 0, you would get 0. Plugging in 1, you'd get pi. Plugging in 2, you get 2 pi, and then 3 pi, and then 4 pi, and then 5 pi. We get our issues. So we cannot have pi k. So what about range? So with range, what we're going to do is look at our graph of sine and cosine and see how they work and see what they go through. So right now we have our a equals 1, so this is just plain old sine. And so if I push play, as it goes through, you can see our sine values. And we're moving, sine is the y value. So we go from 0 to 1 to 0 to negative 1 to 0 and so on and so on. So what it's doing is it's alternating. It's going up to 1 and then down to 1, and then back up to 1. So this red line, that is our range. And so you can see it went up to a high of 1, and then our y value goes down to a low of -1, and so on and so on. So it alternates between -1 and 1. Now, cosine does the same exact thing. It just starts at 1, goes down to -1, and then back up to 1, and so on. So the range for sine and cosine is -1 to 1. And the range for cosine is also -1 to 1. And so what that means is these are all fractions, nice proper fractions between -1 and 1. So cosecant and secant then are the reciprocals. So if you take fractions and flip them, like 1/2, you get 2. And so these are all the numbers that are not fractions. They're bigger than 1 and less than -1. Secant works the same way. So cosecant would be less than -1, greater than 1, less than -1, and 1. So like if you had 1/3, that would be 3. 1/5, 5. 1/8, 8, and so on and so on. Let's get rid of them so they don't confuse you anymore. But yeah, so -1 to 1 is your sine. Cosecant would be less than -1 and greater than 1. So together they make all real. Okay. Tangent. Remember, flipping was 1 and 1, so that works perfect. Now let's look at tangent. So here's a circle, and tangent gets its name because it is the tangent line that makes our triangle. So as I go up to infinity, you see the triangle being formed, right? Our tangent is this value here. So you can see that they match perfectly. See, coming up and down. And so as it goes up and up and up and up and up. And if you think about it, if you make this line go up, and that's the height here, it's going to just go off to infinity. And in the same way as if you make that triangle negative, see, it's negative now, it's just going to go off to -infinity. So with tangent, it comes up from -infinity all the way back up to +infinity. That would be our range. And you can see at -π/2 and π/2, our domain issues, that's where we get our vertical asymptotes. So tangent and then also its reciprocal cotangent go from -infinity to +infinity. And there is your domain and range. Thank you.